Hello and welcome to another Amati Insights call. As usual, before we start, please do take time to look at the on-screen disclaimer, which is also available on our website. Obviously, this is here just to remind you that what we're discussing today doesn't constitute investment advice. Everyone's circumstances are different, and it's essential to do your own research or consult a professional for investment advice that's tailored to you. But that said, this week's conversation is about auto semiconductors, and we're calling it the new chapters of growth 2.0, if you like. Auto and industrial semiconductors are often kind of used interchangeably. Many of the terms are the same. They have very similar commonalities across the technology. But things have been changing, and we thought it would be useful to have a bit of a recap on some of the underlying tech and the drivers of demand there.
Yeah, I mean, it's a broad subject, and we think there are three categories of auto and, by extension, industrial semiconductors that are particularly interesting to us. The first is the broad subject of power semiconductors. What does that mean? If you think about the electric car, for example, the electric power that circulates through it is much higher voltage than you'd normally encounter in, say, an electronics device. Even traditional auto circuitries, the stuff that we've remember for years is 12 volts, but that is moving 48 volts as more and more functions of the car being electrified. And for the drivetrain, for what actually makes the car drive, electric car, electrified car drive, it's started at 400 volts, it's moving to 800 volts for newer EVs, and there are plans for higher voltages. So it's a completely different world. Even even the materials I use in that space are different. There are silicon chips, something we're familiar in the semiconductor world with, but even they had a different design, or I should say, materials process called IGBT silicon. But high voltages require different materials altogether. For example, silicon carbide and gallium nitride, so SiC and GaN, as they're known in the industry. So power semiconductors is one category that matters. The other one is specialist sensors, and there are sensors that look outside the car, and there are also sensors that make the car self-aware, if you like. The outside the car sensors are things like radar and LiDAR, and these are pretty new things, but the names can speak for themselves. They're particularly relevant to automatic assistance, driver assistance, and autonomous driving purposes. The internal sensors are sensors that measure the flow of electricity within the car circuitry, such as related to battery charge and discharge cycle or the functioning of the engine, but also sensors related to positioning and angle of different moving parts in the car. And then finally, there are the brains. There's a saying that modern cars are becoming computer on wheels, and there's a particular class of chips that are the CPUs, if you like, the processors of those computers on wheels. They're MCUs and MPUs, kind of edge intelligence devices, which are effectively little computer chips doing fairly sophisticated computational tasks, but they have to be ruggedized, they have to be industrial and auto-grade, function at different temperature ranges, handle vibration well, etc. So that's the third category that really matters.
Yeah. It might be useful just to kind of recap some of the sort of environment we've been in for demand. So, as many of you will remember, EV was a very strong growth area back at the beginning of the decade. So we saw very rapid rise of Tesla, very opportunistic and optimistic sort of views about the energy transition, and we saw significant support from governments. So a lot of sentiment was very positive, and the fundamentals all seem to be going the right way. But since then, things have changed quite significantly. So there's been a number of policy pivots. I mean, particularly under President Trump, we've seen subsidies removed or reduced. We've seen a significant increase in competition. So a lot of the traditional automakers, the internal combustion or ICE companies trying to develop EV businesses with more or less success, mostly less success, particularly in the US. Some of the big OEMs like Ford and GM invested a huge amount and then backtracked quite significantly from that. And we've seen some of the smaller players, less well-known companies like Lucid and Rivian, that have really seen some financial distress. And obviously, meanwhile, in the background, the Chinese have been coming on leaps and bounds, and we've seen a huge success story there, which has put even more pressure on Western OEMs. So that's been a very big shift in the environment, but also because of the dominance of China, we're seeing more of a localization towards their own domestic supply chain, maybe away from some of the traditional Western suppliers. Likewise, self-driving has been something that's promised a lot and was obviously going to be a big market for semiconductors. That's been something that's taken longer, and obviously there's a lot of regulatory issues that those companies face. But again, we've seen some significant failures and exits. Apple gave up. GM with their Cruise initiative gave up. Ford, Argo, the same. So all of that's been going on. And meanwhile, we had a period, as again, some of you will remember, in the early 2020s, I think around 2022, when we had a very big shortage of semiconductors for the automotive industry. So not only have we had kind of a double whammy of a big, regress, if you like, in demand for EVs, but also that was hit by lack of availability of semis. So things have been pretty grim for a while now, but we do see some new sources of demand, Mikhail, right?
Yeah, I mean, no conversation is complete without AI, and AI comes to the rescue in this category as well. So, AI power has emerged as a really interesting source of demand for mostly power semiconductors, but not just that. And if you think about it, if you imagine, an AI data center, there's kind of mainline power coming into it, and then it steps down multiple times, kind of to within the building, to down to the rack, down to the server, down to the chip. The whole thing is very power hungry, and this power stages, this kind of multi-stage power conversion needs, map very nicely to the problem that the auto EV power had solved already. So even voltages are similar. Like it starts with kind of 800, 400 volt down to 230, 48, 12, and sub voltages, sub single volt voltages on the board level. And we're seeing the application of the same power semiconductors, including this new material, silicon carbide, gallium nitride power semiconductors for the AI power level, and it is making a real difference to the companies. A very consolidated cottage industry, as we like to call it, of power semiconductor companies that have found a great new market and rapidly growing new market for their widgets. So Infineon, which is a portfolio holding for us, now forecasts data center power revenues of 2.5 billion per annum over the next couple of years. That's up from pretty much nothing a couple of years ago. If you talked about Infineon 4 years ago, data center power barely registered. Allegro, which is now a portfolio holding of ours, has really striking statistics in their category of power management chips and power sensors, current sensors. Their content per rack, which is a kind of a clump of servers, went from $20 in the traditional kind of 2023 data center to $150, so over sevenfold increase for rack and data center today, and it's forecast to grow another 3x over the next few years. So, this core AI power is very very compelling new market, but peripheral to that are also things like cooling, for example. And one of the really interesting applications for Allegro chips is motor drivers for cooling fans. We all know that AI data centers run very hot. There's a lot of cooling fans and pumps, and they need to be managed by semiconductors again. So this a nice, I want to say little incremental market, but it's not little at all. It's billions and billions.
Yeah. But just bringing it back to the auto market, I mean, is the auto market still in the doldrums, in a difficult place?
It's emerging from a difficult place, and there's a bit of an underlying growth there anyway. I mean, if you speak to OEMs, which we do, of course, regularly, their long-term plan, their end game is still electrification. And in fact, the industry is talking about, some tipping points, some markets where a combination of acceptable cost, ubiquitous charging infrastructure, and a kind of disappearance of range anxiety as cars become longer range and you don't have to worry about the chargers anymore, reaches the point where EV is becoming a default choice. But there's also what we call electrification by stealth. So this term XEV, which is not just battery electric vehicles, it's plug-in hybrid electric vehicles, extended range hybrid electric vehicles, a very popular category in China, but it's going global, where you have a little top-up generator on top of the EV. You know, they were 25% of all cars produced in 2025, a significant amount already, and the industry forecasts it to get to 45 in 2030. So kind of almost doubling. And these are not necessarily the blue sky scenarios painted at the peak of the enthusiasm in 2021, but still it's a robust tailwind. And even with, you know, without the kind of this bigger picture electrification trends, different functions of the car are becoming electrically actuated, as the industry calls it. There's this acronym we like called XBW, X by wire, something by wire, drive by wire, steer by wire, brake by wire, where there's a mechanical disconnect, for example, between your steering wheel or your brake pedal and the actual rotation of the steering column and wheels and the application of brake pads. And of course, all these actions need to be made by some force. That's not your muscles anymore. It's not hydraulics anymore. It's the electric actuation, and that needs semiconductors that manage it. So there's a bit of growth going there. And then the autonomous driving dream, you know, okay, it isn't developing as much as people may have hoped, but it's still happening to a degree. The ADAS functions, the lower level ADAS functions continue to proliferate. Automated braking, emergency braking, automated lane assist. You know, they're going from at least something of that nature from 60% of the cars in 2025 to 80% in 2030. And again, that draws in the semiconductor content.
Right. Yeah. I mean, in the industrial world, we hear much more about software-defined automation, software-defined networks, and these kind of things. And that's obviously coming to the auto industry, software-defined vehicles. But what is that exactly, and how does it change things?
It's just beginning, and what it is, you know, imagine, you know, at the moment there are lots and lots of what's called ECUs, electronic control units, the little chips, little bits and pieces that control, you know, the opening and closing of a window, or, you know, the functioning of your car stereo. They are consolidating into a zonal architecture. You know, there'll be units devoted to infotainment, to comfort, to driving assistance, to safety, to battery management, and within that there'll be apps that do different things. So that's why it's software defined. You know, it consolidates into sort of mini computers that run different functions of the car, running different apps. And of course, these mini computers require this MPUs, this processing units, to run on. So actually, a software-defined vehicle saves cost and weight when it comes to, you know, really dumb electronics and wires, but adds a lot of semiconductor content when it comes to this processors. And again, we are early in that journey, but you know, there are nice growth trajectories, and some of the major, well, most major OEMs, you know, the Volkswagens, Fords of this world, are still yet to roll out the software-defined vehicle platform. So it's all ahead of us.
Yeah, it's interesting because it's such a big issue in the industrial world, and in fact, I think a lot of the things we've talked about have crossovers into industrial as well as into AI data centers, as you mentioned. You know, when I was recently at the Hannover Messe Industrial Technology show in Germany, and here you just see a huge take up and proliferation of sensors and automation, robotics. And again, as you talk about the kind of electrification of what were previously hydraulic or pneumatic processes, and that's on display in lots of places. And again, this pulls in those kind of power control, power management semis. And we're seeing demand growing on the industrial side. Just really, it's been something that's been talked about for a while, but the whole process of deglobalization that we now see in chain, you know, that's actually happening, this kind of reshoring or nearshoring, that's driving a lot of investment into industrial automation, and again, driving this content in this semiconductor content demand. And robotics in particular is a big area. So not only the much vaunted humanoid robotics, but also just, you know, now more normal quadruped. We see lots of quadruped robots. We see lots of automated mobile robots going around warehouses, and this is a huge demand driver for the whole semis category we're talking about. But are we seeing it yet in the companies? I mean, we hear a lot about it at these kind of shows, but is it coming up in the results yet?
It is starting to. So we had we're in the middle of results season. We've seen some really encouraging reports. Texas Instruments, which is a bit of a kind of industrial semis bellwether, has really strong results. The industrial segment grew 20% quarter on quarter, and they're citing broad acceleration across the board. They're also seeing a lot of traction in the data center related semiconductor business. In more niche areas, Allegro, one of the companies we've alluded to, our portfolio holding, clearly seen very rapid content growth per car. So bulk of their sales is still in autos, and auto sales are up 18%. Now we know for certain that the car market itself, the volumes haven't been going up 18%. It's pretty stagnant. So it just shows that the next generation of these cars need a lot more semiconductor content, and specifically Allegro semiconductors. We're seeing that driving pretty rapid growth. And then the cycle is still there. And we normally look through the cycle. We take a 3 to 5 year approach and kind of cycle ebbs and flows. We're certainly aware of it. And cycle might now work in our favor. Destocking is over, inventory is normal, and there are some pockets of shortages emerging. There was a little scare in the industry, a few months ago when a little-known company called Nexperia in Netherlands, but Chinese-owned, has been sort of restricted in its ability to do business because of the geopolitical consternation between U.S., Netherlands, and China. Another one, and suddenly the auto industry realized, oh, we might be entering another shortage era. So there was a bit of a pull-in of the inventory to make sure they don't run out of chips, and had to stop production lines again. So we might, we don't bet on the cycle, but it looks like over the next 12 months onwards, we might see both structural and cyclical drivers align and be in our favor. So as a result, we will continue to look very optimistically to the auto and industrial semiconductor space. I want to say it's about 6-7% of our fund today, and we're certainly open to adding it to it if good opportunities appear.
Yeah, it's a fascinating area. There's quite a lot more we could talk about, but we've actually run out of time. In fact, we've gone over time, so we should probably leave it for this week. But thanks very much for listening and for continued support, and we'll see you in a couple of weeks' time.